Chapter 7, Think and Rank. Number 51, you have the mass and speed of three vehicles. Rank them in terms of momentum, kinetic energy, and the work to bring them up to their respective speeds from rest. All right, so momentum is just mass times velocity. So the first one is going to be 800 kilogram meters per second. The second is 2,000 kilogram meters per second. And the third one is 720 kilogram meters per second. So the ranking there, B, A, C, if I kept track of it properly. Kinetic energy, you're plugging into the formula, which all of you should know, 1/2 mv squared. And so 1/2 times the mass times the speed squared. So the first one would end up being 400 joules of energy. Kinetic energy, the second one is, 500 times 4, so 2,000 joules of energy. And the last one, 64 times 1/2 times 90. So that's the kinetic energy. So the work done to bring them up to speed, the minimum amount of work is equal to the change in energy. And the boar has just grabbed a receipt for some reason. He's got obviously a very distinct predator. He has a large predator instinct for paper. I'm sure the mice are quaking. So 52, a ball is released from rest from metal track, and rank them again, momentums at the various points, and then kinetic energy and potential energy. It's actually easier. Let's do potential energy. So the potential energy involved here is the gravitational potential energy, because you basically have weight and normal force acting on it. Normal force doesn't contribute to potential energy. The weight does. So the higher up it is, the more potential energy, since it's gravitational potential. And so in terms of ranking potential energy, it's A, B, and D are tied, and then C. C is the lowest. Now kinetic energy is going to be the opposite, because as one gains, the other one loses. And so the kinetic energy will be C, then B and D, then A. Now kinetic energy is the energy based upon the speed of an object. And so therefore, momentum is also ranked upon speed, or velocity really. So momentum, if we're looking at magnitude of momentum, that would be C, B, and D tied, then A. Very similar to number 53. Again, potential energy, I think, is the simplest one here. It's the last one he asks you to do. But the higher up it is, the more gravitational potential energy. There's no other potential energy involved in this particular one. We don't have springs. There's no electric force. There's none of that other stuff. So we have A is the highest potential energy, then E, then C, then B, then D. D is lower than B in this case, just based upon the drawing. Kinetic energy is going to be the flip of that. The more potential energy you have, the less kinetic you have. Excuse me. And flipping that, the more kinetic energy, the less potential. So kinetic energy will be D, B, C, E, A. And then speed is going to be linked right along with the kinetic energy, since the mass we assume is the same. So if I'm doing 1/2 mv squared, the more speed, the more kinetic energy, and vice versa, given the constant mass. And then number 54, this one's probably going to be a little bit tricky to talk through, but it's actually a chapter 2 problem. I'm not quite sure why Hewitt put it into the energy, other than work in is equal to work out, but he doesn't talk about the distance moved. But in A, you have one rope acting up on the mass, so in order to move the mass, you basically are applying that force to move it. In B, you have 2 ropes acting up on the mass. Oh, sorry about the gesture. Two forces acting up on the mass, and so he only has to apply half the weight. The force is half the weight of the block, because it's going to get doubled up at the pulley. And with C also, again, you have 2 ropes acting up on this pulley mass combination, and therefore the force he needs to apply is basically adding tension to the string. If it's let's say it's a 1,000 Newton block, then if he applies 500 Newtons of force in C, you have 2 tensions, 2 500 Newton forces to offset the 1,000 Newton block. And I hope I said the numbers right there. But that's it for Think and Rank for chapter